So I'm going to talk about today is a CAPE and the technology from science. So I'm the director of CAPE at the University of Cambridge, and the CAPE is the organization has been running with industrial partners in the past 15 years. And it's based on our understanding our world is an engineered world. So you can see this is another view from the sky, and what you can see on the world, all the infrastructures and all the activities there are supported by engineering. From the lights, from the information flows, from the traffic, trains, flights, and of course, shippings as well. And in this world, we are facing unprecedented challenges. So we have the problem with the energy, resources, and the climate change, and that has been on the top of agenda of many people. And don't forget, because of the improving medical health care, we have an aging society, and we have a lot of society problems with people getting old. And we also have the financial crisis, credit crunch, and etc. It's unavoidable, people focusing on money. And last but not least, we have a pandemic currently ongoing around the world. So all of these unprecedented challenges are the solutions are lay within the global effort and for the global challenge. And we would like to call the grand challenges and for the solutions or proposals for people working together, find the way forward, and also to work with industrial partners which are strategically placed in the world and along the supply chain to work together for tangible solutions. That's for the benefit of everybody and also for the whole society, humankind. And within this, I think we need societal-driven innovation with industrial collaboration. So we have energy, transport, urban infrastructure. We have a communication network, information security, and intelligence. We have a challenge in uncertainty, risk, and resilience. And we also, of course, have a life science and healthcare. And we have this inspiring research through industrial collaboration, which are not only just the science discovery push, but the market pull as well. All this together, we need innovative research with multidisciplinary interactions and including with industrial partners. So the technology development requires collaboration, not only just because of the needs, but also because it's difficult to cover everything now by a single organization or even a single country. So even it is very large, I appreciate the GSK is very large, one of the biggest company in the world, but still there's a limit there. So focusing resources for maintaining critical mass is needed, and the differentiation of activities for unique contributions, which can get the people from the industry, from the university, from the other parts of the value chain, all working together. So the collaboration among the players with complementary roles and interdisciplinary stimulation. And this is where the university can come in as well. So this is where I think the CAPE model for the technology from science is coming from. The CAPE stands for the Center for Advanced Photonics and Electronics because its origin is in the Electrical Engineering Division of the University of Cambridge. It set up a mission at the onset of its activity to invent and develop, through multidisciplinary research, the materials, processes, components, and the systems. So you can see the processes here are quite often omitted in any other university's part, but yes, in CAPE, this is the essential part of it. And so that we can define the future strategy and the market implementation, and also set the industry agenda for the convergence of photonic and electronic technology platforms. We said that about 15 years ago. We are very pleased to see the things are going that direction with integrated photonics and with the semiconductor manufacturing platform. So the CAPE itself is a unique partnership between Cambridge University and the strategic industrial partners. So we have this model, we work together as partners, not the industry come to university, pay subscriptions. It's not like that. We jointly decide the direction and for the research, which I think is unique in the world. So this provides a new form of joint university and industry research that we hope is leading edge, vertically integrated, and commercially relevant. So the CAPE's objectives are threefold. We have a technology advancement through landscaping and project work. So it's not only just the research work itself, but also the planning. And it has the business opportunities between the partner companies. So we have one partners sponsor the research and make it into the production in another partner's company. And we have the outreach activities to wider community, something like today's event. So we aimed for CAPE delivers technology from science. CAPE promotes the open innovation through its partnership. So we are not doing the open innovation for all as the commonly promoted. I know probably some people driving to that direction for various different reasons, but for the CAPE itself, we promote open innovation through its partnership within the CAPE. And the CAPE create business opportunities and the future vision. So the current partners, you can see the logos list. I'm not going through one by them, and also some of the past CAPE partners and associates. You can see that covers a wider range of the industry, particularly in the electronic and the photonic directions, but also on the consumer's side and up to the materials end. And also we had even financial investors as the venture investor part of it as well. So in the past few years, or the 10, 15 years, we have accumulated about more than 20 million pounds research fund and leveraged about 26 million pounds of the research funding. And so we have had 42 CAPE projects. I think now it's a bit more, about 45 now. We just had a meeting this morning, approved a few more projects. So we have about 10 partners in the past. We've been selective, and people join the partner join the CAPE and has to have some willingness to work with each other together. And we have the principal investigators in the university across several different departments, and we sponsored nearly 50 researchers. And we also doing our best to support the university activities from undergraduate study and to the postgraduate students want to do some research themselves, to the postdoctoral research levels, we give them the fund enough for them to do a short 6 months projects of their own. So this is a good platform for them to have a taste of being a person in charge of your own research program. I think it is a valuable experience for the young researchers and also for the students as well. So we have arranged many CAPE lectures. We have publications and patents as well, of course. So here are some examples here. This is a product and being in production nearly 10 years ago. No, sorry, about 7 years ago and 8 years ago. Is on the Jaguar Land Rover's whole range. This one is on the Range Rover Evoque head-up displays with a laser and holographic display. And it was developed by a partner called Alps Electronics, and then its products used on the Jaguar Land Rover, another partner. And we also have been working with Jaguar Land Rover to develop 3D immersive head-up displays. You can see this is on the display, not only just to look after the driver during the driving, we also look after the passengers as well. And we have been working with the CLRC to build the world first on the train or the trams head-up displays to work in the urban environment and the high-speed train on the tracks in China. And the group of the Jaguar Land Rover researchers work with the design center in the Cambridge and also information science people in the Cambridge, developed the contactless touch technology. So as you probably can recall your experience, when you're driving, you wanted to use the touch panel on the central console, and it's not easy. And if you are driving a Land Rover on the terrain, and that can be quite a challenge because it's uneven surface, quite wobbly. So the people here in the Cape develop a technology. You can do the contactless touch by pointing finger, moving towards one direction, which panel you wanted to touch to, and then the button, and it will select according to your effort to focus on that. So that can be a quite easy and successful now implemented now in production. And this also provide a contactless means, so we can do the health care and prevent the contact spread the virus and etc. And further than that, there's another group of the people developed the so-called the structured electronics for personalization. So this is the ways to use printed electronics and forming the customized electronics in the car or in other applications to reduce the weight significantly and provide a faster prototyping and provide a customization for the people to use it. So the surface here, you probably see some, if you can see my cursor, some of the patterns here. So underneath of it are all the parts of electronics, including the control buttons, the sensors, and many other controls as well. So they can customize, integrated to different facades and the interior parts. And we're also working with material developers, and this is a multi-stable smart glass demonstrator, which use the material developed by Dow Corning and then work with the university to have it developed in the way of not only in glass cells, but also in the flexible plastic laminated panels. So these are tiled plastic laminated panels. And these are different from the PDLC's one, needed to have the power to maintain a state. This is multi-stable, so each state can stay there for as long as you like. And the transparency and the scattering performance has been optimized. From the photos here, you can see, apart from the substrate, you do not see any residual effect of the material on the transparency. And when it's scattered and provide a very good protection for the privacy. Of course, we are also using it used for the light radiation control, modulating the light and the heating within the room as well. Finally, I would like to show you a video, which is a head-mounted display the Cape working with Huawei developed. And as you know, in the 3D head-mounted displays, the common problem is they call the vergence and conflicts. People have the different depths of the views, but because it's on the screen, would image a traditional way to show is only on the part of the fixed distance, and your eyes expect a different distance has a clear image in different ways. So let me replay it. So the purpose here is to be able to show an image which are at a different distance, but always clear to your mind. So we can relax on the focusing side, but maintain the convergence to show the 3D. And we have been tested on many people to show it has no dazzling or dizzy effect. So you can see the image produced on the left-hand side is an image shown by the head-mounted display. On the right-hand side is the parts. Let me repeat a bit. The right-hand side is to show at the different distances when the camera focus changes, the image maintain clear all the time. So by doing that, you can see 3D images and without causing the side effect, the headache. So I think I should stop here and thank you very much